Okay, all right. So good morning, good afternoon, good evening from everywhere you might be joining us from. I welcome everybody. So my name is Oladapo Babalola, and I am one of the co-founders of DevOps as a Service Nigeria, also known as daas.ng, which is a free DevOps mentorship platform to mentor the next generation DevOps practitioners, that will learn, innovate, disrupt their various IT spaces with the DevOps culture, DevOps skills, and the understanding needed to thrive, in the modern workplace. So on behalf of my co-founders, Oluwaseun and Nuruddin, I welcome you all. So apologies, last week we couldn't hold because I think there was a nationwide, network instability within the ISP. So we couldn't hold a class last week Saturday, but here we are today, talking about Kubernetes. Okay, so we'll just jump right into it without wasting much of our time. So I will just stop sharing my video. Okay, right, please kindly confirm that you can still hear me.
You are loud and clear.
Okay, all right. So so today we're going to be talking about a very important topic, right? Kubernetes. I know so many people would have heard of Kubernetes. So many people would have used Kubernetes, right? But today we're going to be talking about the concepts. Why do we use Kubernetes? Like, what is the force about Kubernetes? Why do everybody talk about Kubernetes? Why is it a major skill needed within the DevOps space itself? So Kubernetes really is an open source platform that automates Linux container operations, or I can actually put it like this: it also automates container operations itself. So this platform, right, was first developed by a team at Google. And after they developed this, they used it for a few years, and then it was later donated to CNCF. Now, CNCF is Cloud Native Computing Foundation, which is another open source software foundation that promotes adoption of cloud native computing. And really, they hold developer conferences around the world. So thanks a lot again to CNCF, because they are the minds behind anything open source. So Google really saw what they are doing. They saw what CNCF, like the great work they've been doing, and so they donated Kubernetes to CNCF itself. Now, to better understand Kubernetes, let us think of it this way. Now, let me just bring in a picture. I'm sure you can see my screen. I'll just import the picture that I have here. Sorry. Just a minute. Let me just look for a picture of an orchestra. Good. So if you can see my screen, let me just choose this one. If you can see my screen, right, you would realize that we have a guy who most people will call a conductor. Right. Now, this guy is a guy that would tell how many trumpets are needed. It would tell how many violins, drums, who are the guys that will play first, who are the guys that would play the violin first, how loud can they play, and so on and so forth. Now, this guy itself, definitely they call him the conductor, and is the guy in charge of conducting an orchestra itself. So you can just think of this guy as Kubernetes. So just think of this guy as Kubernetes. As time goes on, we'll talk more on what this guy does itself. Now, moving on, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. But before we go on, I would encourage everybody to just watch this documentary. It's a wonderful documentary about Kubernetes. Now, these are the guys that actually started Kubernetes. You know, talk about, what is his name again? Tim Hopkins, you know, Craig, Cleese, Vilhikers, you know, wonderful guys. So I would just encourage everybody, if you have time, you can just watch this. You can just watch this this documentary talking about Kubernetes. You can watch the part 1 and part 2, so that at least you can have an idea about Kubernetes. Now, how did we get here in the first place? How did we get here in the first place? Now, we got here because we wanted our applications to run without any operating system. Remember, during our first class, we were talking about Docker. Now, the reason why we needed Docker was because of the operating system constraints. Meaning, if we want to deploy several applications, right, and want to ensure high availability, it means traditionally what we have to do is that we have to start creating servers, you know, start creating different VMs that, of course, would come with their own operating system. But instead of doing that, thanks to Docker, the only thing that we just need to do is just to, you know, deploy our applications with their libraries, their dependencies, and their packages, so that they don't have to rely on the underlying operating system itself for them to be able to run, right? And this itself can be done on what we call the container engine. We discussed this during the last class. So just to refresh our brain, let us quickly draw the architecture again, so that at least we would understand what it is we are saying. Now, this is the host. This is the server itself, right? Now, within the server, of course, would have what we call, okay, this is the entire system, right? Now, within the entire system, we have the server, which is here. So I can call this guy the infrastructure. Right. On the infrastructure, I have the host's operating system. I'll just call this guy the OS. On top of it, remember, that's where we deploy the Docker engine itself. And then on top of the Docker engine, you know, we can now talk about deploying our containers itself. So this is a container. And then within the container, we have the dependencies, we have the packages, the libraries, and the application itself.
No, is it my network or is that for having some time disconnections?
Oh, can you guys hear me well?
I don't know whether it's my network, but I'm struggling to hear you. Sometimes it will breaking.
Okay, that's the minute.
Your net.
Okay, what about now?
Okay, loud and clear.
Oh, okay, cool. Can you still see my screen?
Yes.
Okay, cool.
Yeah, we can see your screen.
Yeah, so I was talking about the architecture of how, you know, you would deploy your container itself. So I said this is the entire system, right? Within that system, we have the infrastructure. You can see this guy as your host server itself, at the physical server, right? Now, on top of that physical server, you will install what we call an operating system. Now, on top of that operating system, meaning you have actually installed your Windows 20, maybe your Windows 2016 or your Windows 2019, whatever it is that you want to install, you have actually installed that. Then on top of that, you have what we call the Docker engine. Now, on top of that Docker engine, it's where you will now run your containers. So this is container 1, right? Now, within this container, what do we have? Remember that during our last class, we talked about that a container does not need an operating system to run. But the only thing that the container needs to run is just the Docker engine and the application itself, which is here. The application, the libraries, and some other maybe packages or dependencies, or those dependencies. Right. So this same thing applies across if we have multiple containers. So this is another container. This is another container. Remember, this was what we were able to establish during our last class. Now, okay, we are happy that our containers are running within this particular host. But by the time we start deploying so many applications, what it now means is that we have so many containers that will be growing. At the same time, it also means that we have to now deploy, new servers. Like the way we have here, right? We are having, let's say on this particular host now, we have, let's say, logically, let's say we have 50 containers. 50 containers on this particular machine itself. So if I want to scale, it means I have to duplicate whatever I have here and scale it this way. I don't know, can I move to the other side? Okay, I can't move to the other side. You understand the logic? It means if I want to scale, I would have to, create another Linux machine and then deploy the different containers across the Linux environment itself. But this, in a long run, is going to cause so many havoc within your system itself. Now, the question now is, who will look after the container health when they need resources? Who will bring these containers back up when they go down? And that is where we now need to recruit this guy. We need to recruit this guy. And this guy would have to look after our containers when they go down. We have to give our containers more resources. And that guy is the captain. And the captain is called Kubernetes, because Kubernetes is highly available and efficient. Now, let me just recap. We have our containers. Our containers are running beautifully. They are running on our infrastructure. There are about 50 containers handling different processes, sitting comfortably on the Linux environment. Now we need to scale. We need to add more application stack to what we have. Then it means that we have to now provision another Linux environment, deploy the containers. But once we have so many containers, we need a captain to ensure that these containers are up and running. Else, as a DevOps practitioner, it means you'll be the one that will now, always monitor your container, because containers can go down at any time. But we need an automator, which is a captain, to ensure that all of these containers are actually brought back up. If they need resources, that captain is there to give them food, which is the resources. If they need water, that captain is there, right? If they need to move to another Linux server, that captain is there to ensure that they have easy movements to another server itself. Now, a point to note here is that we have so many orchestration technologies, meaning we have so many captains. It's not only Kubernetes that we have. We have Docker Swarm, and we have Mesh OS. Now, Mesh OS was actually built by Apache. Right? That does the same thing that Kubernetes does as well. But Kubernetes is just very popular because it's very, very easy to understand. It's highly scalable and efficient. Now, for Docker Swarm does orchestration as well, but it is not as robust as Kubernetes. Again, Docker Swarm is the easiest to set up, but Kubernetes and Mesh OS, which was actually deployed by Apache, are not that easy to set up. But again, you can actually leverage on the cloud for the different managed services that we have. Okay, does that help? Now, moving forward, we'll talk about the Kubernetes architecture. Now, that guy that would be responsible for making sure that our applications are up and running, when it needs to scale automatically, when we need to, do things around high availability. Let us even understand the architecture. So I'm going to import the diagram here. Let me just delete these guys. So I'm going to import the diagram. Sorry, let me just delete what I have here. Okay, so this is the architecture of Kubernetes itself. Please let us listen very carefully, because once you miss this part, you might find it very difficult to grasp the other things that we are doing. Now, under the Kubernetes architecture, we have what we call the node. Now, this is the node. Remember the last diagram I drew, right? That server itself is called the node, or it can also be called the worker machine. And this is the server that Kubernetes will set up containers. Do you understand? So what that means is that these are different worker machines, or you can call them different nodes. So this is Mr. Kubernetes here. Now, Kubernetes has some pods. Let's say these are let me say Kubernetes has some applications to deploy. So what Kubernetes would do is that Kubernetes would take these applications that need to be deployed, and then it would deploy them on these nodes. You can deploy them on these nodes or on several nodes that we have. You can also deploy them on several nodes. Now, these nodes are called workers. They can be called worker nodes, or they can also be called worker machines. And that is the server that Kubernetes will set up containers on. Right. Now, cluster. Let's talk about cluster. What is the cluster? A cluster is just the collection of all of these nodes together. So by the time you hear the word cluster, cluster is just collection of my worker nodes. I can have another worker nodes here. I can have another worker node. All of these guys can be grouped under what we call a cluster. Now, the question now is, by the time we have so many clusters, by the time we have so many worker nodes, who is the guy, or what is that thing that will be responsible for keeping information about this node? Because of course, once we have nodes within our cluster, we need to keep an information about all of those nodes. Now, who is the guy that will be responsible for keeping the nodes? Who is the guy that will be responsible for managing the cluster? How are the nodes monitored? When a node failed, how are the containers migrated to another node? All of these functions are done by the master node. You can see this is the master node here, or you can also call it Kubernetes master. So this is like the brain box of the Kubernetes application itself. Right now, within the Kubernetes master itself, right, this can also be called control plane. So Kubernetes master can be used interchangeably with the concept called control plane. So once you hear control plane, just know that they're actually talking about like the brain box within the Kubernetes cluster itself. I'm just taking my time to explain all of this so that by the time we move on, by the time we start talking about etcd, API server, you know what they do. Now, API server, when you hear the word API, right, the first thing that comes to your mind is connection, communication, right? Now, this is the front end for connection to the Kubernetes cluster. So let's say I have a guy here with his laptop. He needs to do some things within the Kubernetes cluster itself. He needs to perform some functions. right? It needs to connect to the control plane. But in a way, it's not just connecting to the control plane, it's connecting to an API that has been exposed by this API server. So APIs, so the API server, just deals with communication to the cluster. This is like the front gates to enter the cluster itself. So that's the basic function of the API server. And this is a common interview question. They will tell you that, okay, please, can you tell us the different objects or the different components of the control plane? Then you can now start talking about the API server and the rest. Now, the next one is called the etcd. Etcd is just a distributed key value store. You can see it as the database to store information in the cluster. So information like what? Like the node information, the cluster information, pod information, and then it stores the actual and the desired states of the cluster. Very important. So you can see the etcd as the database, that keeps information about everything that is happening within the cluster. That is what etcd does. Scheduler is just responsible for distributing container to nodes. So you can see here, when I talked about the Kubernetes itself, now the scheduler components sitting within the control plane is the guy that is responsible for distributing containers to the nodes. So that's what the scheduler does itself. Okay, let me just, sorry. I'm going to delete this guy. Okay, let me just remove to make the work to be cleaner, the board to be cleaner a little bit. Okay, now let's go to the controller manager. The controller manager is the guy behind, or is a component. Sorry, I'm using guy. Is the component behind orchestration. They watch to make sure that no container goes down. And if they do, this service is responsible to bring the containers back up. So the controller manager saying that Mr. Scheduler has, this is the guy again. Let me just draw. These are the nodes. These are the nodes. Scheduler has deployed these containers. He has deployed these containers to the node. He has deployed this container to the nodes. And he has said that at every particular point in time, I want 5 containers to be running. This is 1, 2, 3, 4, 5. I want 5 containers to be running in this node. And on the second node, I want 3 containers to be running within this particular node itself. If for any reason, right, this container goes down, or let's say 2 out of 5 go down, then it's this controller manager. This controller manager is always watching that, okay, the information I have the last time is that 5 of the containers should be running. And on this other guy here, 3 containers should be running. If at any particular point in time, any of these containers should go down, then the controller manager would spin up those 2 guys, or it will spin up all the containers, or it will spin up the container that actually gone down, just to make sure that the original 5 allocation or the original 5 definition is actually running on this particular node itself. Do you understand? So it's a service that is responsible to bring the containers back up once they go down, right? Then another component is called the container runtime. I think as time goes on, we'll talk more on the container runtime itself. Now, the container runtime is just the underlying software that is used to run containers. Do you understand? Now, let us go to kubelets. You can see we're now back to the nodes, to the node itself. Now, what are kubelets? Kubelets is the agents that runs on all the worker nodes. You can see I have a kubelet here. I have another kubelet over here. Now, this is the agent that runs on the worker nodes, and they relay information to the master to ensure that containers are running as expected. So you can see this kubelet as an ambassador. An ambassador is the guy that represents his country in another country. And that ambassador is responsible for reporting the different affairs or the different affairs of his own citizen in that country back to the president of his country itself. So you can just see it as the German ambassador, right, is responsible for reporting all the affairs of Nigerians in Germany, reporting all the affairs, trying to make sure that at least we have bilateral trades, we have a very good relationship with the German government. So that ambassador, you can just see it as a kubelet, and is responsible for reporting the different activities, the different affairs of Nigerians, reporting it back to the president of his original country, which is President Muhammadu Buhari. So you can just see the president as the master here, and then the ambassador as a kubelet. So at every particular point in time, there's always a connection back to the master, telling him that at this particular point in time, we have 3 ports running. We have 1, 2, 3, 4, 5, 6. We have 7 containers running. If this guy should go down, it will report back that unfortunately, as at this time, we have 2 ports running and 4 containers running. And this will now inform the controller manager. Mr. Controller Manager, please go and do your work to ensure that this pod is up and running. So that is the function of the kubelets. It's just to relay information to the master to ensure that containers are running as expected. Now let us go to the kube proxy. Let's go to the kube proxy. Now, this kube proxy facilitates things around networking to ensure that there's communication within the node and outside the node. So you cannot see this guy as a telecommunication mast, just to ensure that I have connectivity, or sorry, the ports can communicate with each other, and they have connectivity with the different containers and what have you. So the kube proxy is the networking elements within the node itself, just to ensure that we have connectivity. All right, so now moving on, a very common interview question is this. They will tell you that what makes up a Kubernetes master server? The answer, Kube API server, etcd, controller, and scheduler. Very, very common question. I don't even think that you would miss it when you are going for a DevOps role itself. And then they also ask that what makes up a worker? Very simple. Container runtime, kubelets, kube proxy, right? Those are what makes up a worker node itself. So what is kubectl or kube control? Kubectl is spelled this way. Kubectl. Now, this is a command line tool that you always use to deploy applications in your cluster. By the time we start the hands-on, you understand what I'm trying to say. So let me just show you an example now. If I have my laptop here. And I need to interact. Remember, I told you that you have to speak with the API server, right? I need to interact with this cluster. Everything I'm doing will have to be via the command line itself. Now, that command line is called kubectl. So it's kubectl that would enable me to run all the commands that I need to manage the cluster that we have. So kubectl is just like the operating system model that you always use. So anything that you want to do within Kubernetes, you have to type this kubectl as you have. So let me just show you an example. I have, so let's say I want to, don't worry, we'll talk about ports. Let's say I want to get the ports, running within this cluster, or let me say I want to get the nodes. What I just need to do is kubectl get nodes. That's all. So this kubectl is a command line tool that will always use to deploy applications in the cluster. Okay, now, how do we set up Kubernetes? There are different ways we can set up Kubernetes itself. Now, if you want to just play around with Kubernetes on your system, if you want to now, Kubernetes is the same thing everywhere in this particular function on my system. And then if I now go to my friend's PC, it doesn't mean that, you know, Kubernetes that is actually running on my system will be different from the one on my friend's PC. It's the same thing, the same concept, you know, the same engine. The only thing that is just different is just the version. The same way we have, you know, different version of what is it called now? Different version of applications that we have. Or let's say Microsoft Office 2013, you know, definitely there'll be different versions of that. 2013, 2016, Microsoft version 2022, or what have you. But the concept is still the same thing. Now, how do we set up Kubernetes? We can set up Kubernetes using what we call a mini kube. So a mini kube, as the name implies, it's just a mini Kubernetes cluster that you can set up on your PC just to play around with it. Very, very easy to set up. I would encourage you to go through how to set up Minikube. Then another one, we have what's called micro Kubernetes. It's spelled micro K8. Right. Now, someone asked me the last time that why do we label Kubernetes as K8? That is, why is it spelled K8 then S? And the reason is because if you count the number of letters in Kubernetes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, they've now removed these letters, U, B, E, R, N, E, T, S. If you count it, you have how many? 1, 2, 3, 4, 5, 6, 7, 8. So they replaced all these guys with 8 and then left the K and the S. And that was how we came across K8. So by the time you see me, you hear me say K8, you should know that I'm actually referring to Kubernetes itself. So another way of setting up Kubernetes is by using micro K8. You can just check them online. Very easy to set up. The first one I talk about is what? Minikube. You can see Minikube starts is a way to be able to bootstrap Kubernetes itself. They will tell you what you need: 2 CPU, 2 gig of free RAM, 20 gig of free disks, what have you. So they say that Minikube is a local Kubernetes focused on making it easy to learn and develop Kubernetes. So like I said, right, Kubernetes is quite complex when it comes to setting up. But instead of following all of the complexity, right, these guys have been able to do the work for you. That the only thing you just need to do is also follow their methods here. You can see the installation technique. Just follow the different processes here. And within 2-3 minutes, you have a local Kubernetes running on your PC and you'll be good to go. Second one is the micro K8. Micro K8, as you can see here. Same thing as Minikube. You can see lightweight Kubernetes. You understand? So this is used for to be able to bootstrap Kubernetes itself, and you can start working with it. You can just follow the different methods. Now, another one is called the Kube ADM. Kube ADM. Now, this Kube ADM is usually for semi-production based applications. So meaning you can actually set up like different nodes. You can have like maybe like you can have like 5 nodes. You can set up like 5 nodes. So let me just delete this and delete this as well. So what that means is that you can actually set up 5 nodes. Right, and then set up a master. So this master will be the one to manage all of these nodes itself. So a way to do this is by using Kube ADM. So you just follow the steps on how to, and that will be your assignment. You will have to, collaborate with the team to set up Kube ADM, to set up Kubernetes using the kubeadm cluster itself. So if you actually want to bootstrap the Kubernetes itself by having, how many cluster do we have? We have only one cluster that consists of how many nodes? 1, 2, 3, 4, 5, and one master. kubeadm would assist you to do that. But Minikube and micro K8, they only would help you to set up only one node cluster. So you have Kubernetes running just on a single node itself, on one node. So that is what Minikube and micro K8 would help you to do. And that's why I said you cannot really use it for production. It's just for practice sake. Good. So another one is you can, if you don't want to go through all of the headache of setting up Kubernetes on your own, which I won't lie to you, is actually very, very tough, especially if you don't have all of the requirements needed to set up Kubernetes. It can be it can be very, very stressful to set up Kubernetes, right, on physical servers. But if you're on the cloud, hello, can you hear me?
Yes.
We went off for a while, but we are back.
Yes, so sorry. The network has just been misbehaving since morning. Okay, so please, can you remind me, can you tell me where I stopped? I'm not sure, maybe the last
Talking
thing.
about this,
the cloud part.
Kubernetes in your physical server.
Okay, cool. Now, I said it will be very stressful to set up Kubernetes on physical nodes, on physical servers. I can tell you, I've tried it like several times, and it's not easy to set up. Though at the end of the day, once you get it right, you'll just be cruising, you'll be good to go. But setting up, especially on real servers, Red Hat, it's a nightmare to actually set up. But if all your servers are just Ubuntu, CentOS, you'll be good to go, right? So, but if you are running on the cloud, I'm talking about Azure, AWS, Google Cloud, DigitalOcean, what have you. Now, those guys have done an incredible job to ensure that you don't need to set up the control plane, because the difficulty itself is setting up the control plane, etcd, your scheduler, your controller manager, and what have you. Now, what they've done is they've told you that you don't need to set up that. We will take care of that for you. Let me import the image for you again. I just want you guys to understand the concept very well so that once you start working with it. Now, within the cloud itself, right, what they've done is they've told you that, Mr. DevOps, you don't need to worry about this guy, right? The only thing that it does need to do is that we'll take care of this guy for you. And then when it now comes to the payments, you will not pay for this controller, this control plane. But the only thing that you pay for is the worker nodes, because these worker nodes are basically servers. It will tell you that based on the number of ports that we set up, you only pay for the server that are running within your account itself. So a lot of people ask me this question, that where is the payment coming from? You don't pay for this. You don't pay for the control plane. You only pay for the servers that AKS, which is the Azure Kubernetes service, would deploy for you. So by the time let me just show you an example. I think I have, though we'll not go straight into it. Now, this is my Azure environment. And let's say I want to set up Kubernetes. The only thing I don't need to do is just to go to Kubernetes service. Very, very easy to set up. They're telling you that Azure Kubernetes creates whatever. Azure will handle cluster operations, including creating, scaling, upgrading. Okay, I've had you just go to create. It's telling you that create a Kubernetes cluster. So by the time you create this, it would come up with information about resource group, cluster configuration, cluster name, availability zone, Kubernetes version. You can see the version I was talking about, the API server. It's telling you that the API server availability will give you 99.95. It means that your control plane can never go down. And really, it will never go down because these guys do not play with their SLAs. Do you understand? All these cloud providers, they don't just give you an SLA that they won't be able to cover. So now it's telling you about the primary node pool. Now, this node pool are just your node. You understand? And it's telling you that minimum, you can set up at least three nodes for residency. You understand? Meaning they are telling you that the minimum you need is at least you need 3 nodes, 1, 2, and 3. So the only thing that you pay for are these 3 nodes, 1, 2, 3. And by the time you just go ahead, you know, it will now take you to the node pool, access, networking integrations, and what have you, and you'll be good to go. Your Kubernetes will be up and running within the next 5 to 10 minutes, and then you can now start deploying pods to it. So the cloud has actually helped you to simplify the creation of Kubernetes itself. So on Azure, it's called Azure Kubernetes Service, as you can see here, Kubernetes Service. On AWS, it's called EKS, Elastic Kubernetes Service. Then on Google Cloud, it's called GKE. And that is why most of this, once they send you the job description, for a DevOps role, they always tell you that at least you must have knowledge about AKS, EKS, or GKE, which is still the same thing. Don't allow anybody to deceive you. It's still the same thing as, the Kubernetes. That's why I say that Kubernetes is not different across board. They are the same thing. Whether you set up Kubernetes in Jupyter, whether you set it up in Mars, it's still the same thing. But the bootstrapping purposes and the bootstrapping processes, which is creation of the cluster itself, is what differs. And that's why we have different types of setup for Kubernetes. Okay, so moving on, let's talk about the container runtime. Now, another important information is that the containers itself, they will need what we call a container runtime for them to be able to function optimally. So it's just a software that assists Kubernetes in running containers, right? It's called a container runtime. An example is what we call container D. There is container D, there is cryo. I'm just taking my time. I don't want to rush into hands-on because by the time you don't get these concepts, you'll be happy that you know the hands-on. But then once issues starts happening, you won't know where to go to. Okay, so let me just delete all of this. Now, container runtimes. There's container D. There's container D. There's cryo. It's spelled CRIO this way. There is Docker engine, and a whole lot of other container. But the most popular is container D and cryo. Now, someone will ask me that why not Docker engine? And that's because Kubernetes no longer uses Docker engine because there's a small component within. There's a small component. Okay, I don't want to go into the complexity of the Docker engine, but let me just use this to explain to you because I feel you need it. This is Kubernetes, right? Then you have your containers here. So the logic is, this is Kubernetes. This is Kubernetes, and these are my containers. Now the logic is for Kubernetes to be able to interact with my containers, right? There's a need for what we call a container engine, which Kubernetes would use. Kubernetes will use this guy to interact with the different containers. So without the container engine, so this is container engine over here. And these are my containers. I just name them as C. So Kubernetes needs the container engine to be able to interact with containers, right? So an example of container engine is what is called container D. So it means container D is sitting here. Container D is sitting here, or cryo can sit here, or Docker engine. But Kubernetes has phased out Docker engine. They said that we're not going to use Docker engine as, we won't use Docker engine as our container runtime again, because under the hood for Docker engine, there's another guy called Docker shim. What this Docker shim does is that Docker shim is the one that Kubernetes would first communicate with. So this is my Kubernetes. So in a way, Kubernetes is, sorry, let me just take this thing back. In a way, Kubernetes is communicating with this Docker shim, and then under the hood, right, Docker shim is the one that is actually doing the interaction with the container. But Kubernetes has said that no, this will not happen again. Docker shim, you are out of the game. Automatically, container engine 2 will be phased out. So the thing that Kubernetes are no longer supporting is the Docker shim. And of course, since they're no longer supporting Docker shim, it's going to also affect the Docker engine. That is why today we only make use of what? Container D and cryo. So please don't take this information very, very important. Like, just take it as gold, because really, if you go online, you won't be able to understand why Kubernetes actually phased out Docker engine. But this is the secret, because of this Docker shim guy. I don't know why, but Kubernetes has said that they won't support it. They actually stopped supporting Docker engine this year, but they support container D and cryo. Okay, so thus far, do you have any question? If you have any question, please kindly ask. Hello, can you hear me?
Yes, I can hear you.
Okay. Do you have any question before we can go ahead?
Okay, so I think the question I have is basically on a personal note. Like, I've been finding it very difficult to really differentiate between Kubernetes and Docker itself. Yeah, I've not really had opportunity to. I've had opportunity to like learn about it, but I've been having that question within myself.
You're on a speaker.
Hello.
Sorry about that. So sorry about that.
Okay.
So that's actually the question I've been trying to ask myself, but I don't know if you could just maybe like just explain the difference here, and I think that will be fine for me. Thank you.
Okay, yeah, cool. Now, I believe with the information I just passed across now, I'm sure you should already know the difference between Docker and Kubernetes. So let me just explain it again, so that at least you have an idea. So let me just bring back, okay, do I still have the architecture? Remember, I started this way. I said there's a system, right? And within that system, you would need a server, a physical server. Let us call this guy as the physical server, a physical server here. Now, on that physical server, you need an operating system. Let's call that guy an OS. On that OS, we need to run containers. Now, why do we need to run containers? It's just because I don't want to depend on operating system, meaning each time I want to deploy an application, I don't need an operating system before I can actually deploy my application. Because today, VMware, if I want to deploy an application today, I will spin up different servers. On that server, I will install my application. On that on another server, I would install my application. But again, that is not efficient because I will have to always rely on OS patching, rely on bugs. If the OS is having issues, you know, I always have to you know, shut down my applications, or maybe like go through the difficulty in migrating them to another system. Now, what will now help me to abstract, to remove that operating system dependency is what we call Docker engine. And this is the Docker engine here. So on top of this Docker engine is where I will now, you know, spin up different containers that can now help me to run my application. So what this means is that on this container, the only thing I need is just my application, which is here, my app, and the dependencies, the packages, and the packages that are needed for this app to function. Do you understand? So it means this is just the only thing that is needed. So Docker engine would help me to be able to run my application on different containers. So a container is just, as the name implies, it's just a container. It's just like a, how do I even put it now? Just it as a bucket, that within that bucket, I don't need my operating system, or see it as a VM that doesn't have an operating system dependency. The only thing I don't need to have running on that container is just the app and the packages. Now, Docker engine, which is called Docker, is the one that assists you with that. But if you now need to do this across different, oops, sorry. Let me just, if you now need to do this across different infrastructure, you need to do this. Let me replicate it. You need to do this like across, let's say 10 servers. At the end of the day, this is fine, but what will now happen is that you now have to start logging into this system one after the other to check the health of these containers, because customers will start complaining that we cannot access the front page of your service, or the front page of Jumia, for example. Now, the way Jumia is now is that Jumia is running within different containers. That's the front end. It can be running within different containers. But we need a guy that would be able to, you know, orchestrate. Let me not use the word orchestrate now. That would be able to always monitor these different ports. Now, sorry, these different containers. Your containers can span as many as 2,000 containers. How do you want to be able to monitor all of those containers so that when they go down, right, another one can come up automatically? Do you understand? So that when they need resources, there is that guy that would always be available to allocate resources to the containers. Now, that guy is called Kubernetes. Do you understand? So Kubernetes is a software that helps with orchestration. And what is orchestration? It helps with high availability. It helps with resource control. It helps with resiliency. It helps with scalability, name it. And that is why you need these two guys to be in a cluster. So this is a cluster. You need these two guys to be in a cluster. And then you would now get Mr. Kubernetes here to oversee all of these containers that you have. So Kubernetes is far different from Docker. In fact, they are not even related at all. So Kubernetes is an orchestrator that will help you to be able to maintain high availability across your cluster. Does that help? Bedu?
Yes, it helps a lot. Thanks so much.
Okay, all right.
Yeah.
So moving on, we'll talk about ports. Another very important concept. Let me just move this guy. So I will just be very, very basic about it so that we can actually have a common understanding across what it is. And I'm sure that once you have that basic understanding, right, you'll be able to handle Kubernetes. Again, it has a steep learning curve, very simple, but there's so many information that can be missed out. So, but by the time you follow all of the basic things that I'm going to be taking you, hands-on, I'm sure that once you come across the different objects that we have within Kubernetes, you won't have any issue with it. So let's move on. Now, what is a pod? Now, a pod is a single instance of an application. Just see a pod as a container for now. So just see a pod as a container. Remember, I said a container is that bucket that would help you to what? Deploy your application and its dependencies and some other binaries that it needs. It doesn't need to have an OS. So that is a container, right? So in Kubernetes, you can see a container as a pod. That's why I said I just take that information for now, right? So a pod is a single instance of an application, and it's the smallest object that you can create in Kubernetes. I've been to an interview where I think the only question they asked me is that, what is the smallest object I can create in Kubernetes? At first, I'm like, what are these ones saying? Smallest objects. But they're talking about pods. So a pod is the smallest object that I can create in Kubernetes. Now, Kubernetes does not deploy containers directly on nodes. Remember, Docker. Remember the concept of Docker engine that we have here. So Docker will help you to deploy containers directly, right? Containers directly, right? But Kubernetes is saying that there's a new sheriff in town. You don't deploy containers directly on me, but you deploy containers directly into another encapsulation called pod. So this is the container, and this is a pod. Am I making sense?
Yes.
Yes.
Cool. So once you have that information, then you'll be good to go. So that's why I say that you should just keep that information for now, that a pod is not equals to a container, but you only deploy a container inside a pod within the Kubernetes platform itself. So now, what now means that if you need to scale, you don't need to deploy multiple containers in a pod, but instead you deploy multiple pods in a cluster. I'll say that again. If you need to scale, meaning if you need to have so many instances of your application running, unlike Docker, where you deploy multiple containers across, right? The only thing that you don't need to do is that you don't need to deploy multiple containers in a pod, but instead you deploy multiple pods in a cluster. This can be confusing, but let me help you understand again. So this is a node. This is a node. This is another node. On this node, I have my application that I want to deploy. I have my application that I want to deploy. Right. So if it's Docker that is handling this guy, right, I don't need to deploy multiple containers. But if it's Kubernetes, right, what I don't need to do is to have my container sit inside a pod, and then I can now deploy these pods across the different distance that we have, the different nodes that we have. Do you understand? So a container is always going with the pod itself. So on that Kubernetes. Now, there's another notion. Remember I said that within the pod, right, you can have a container within the pod itself. Now you can actually have multiple containers within one pod. But it will be so rare before you have more than one container in a pod, unless you want to use what we call a sidecar container. So a sidecar container does a helper container that is helping this main container that we have here. It's just an helper container, which you will hardly use. And even if you have to use that concept, is because you need something that would always help the main container itself. And that is called a sidecar container or a helper container. But we'll not be looking at that in this lecture, because that is like beyond the scope of this class. Okay, so moving on, how do I create objects? Now, when I'm talking about objects, I'm talking about pods, I'm talking about replica sets, controller manager services, which I'm going to talk about now. If I need to create all of these pods, if I need to create this pod itself now, let me clean this. If I need to create the pod, I need to write, the language that Kubernetes is going to understand. So I cannot go to Germany and be speaking Turkish or be speaking Spanish. Nobody will understand me. You understand? So I need to write a language that Kubernetes understands. So that once Kubernetes is like, oh, okay, you want to create a pod, okay, no problem, I will help you create it. It will just speak that language and then create it. Now that language that will help you to create the different objects, pods, deployments, replica set services, is what we call YAML. YAML is spelled this way, Y-A-M-L. And it's yet another markup language. That is the meaning, yet another markup language. Now, YAML is the de facto language that you use to create different objects in Kubernetes. Follow me. It's used to, represent configuration data using what we call key value pair notation. I will explain it. So let me just launch my Visual Studio Code and then show you an example of YAML. But before we, start talking about the representation of ports and what have you, let me just teach you the rules and regulations within YAML. It's very, very simple, language to understand. Now, don't be scared. We're not writing Python language here. We're not writing Go. We're not writing anything. It's just yet another markup language, which is represented by what we call key value. Now, key value is, I'll show an example of key value. So this is an example of key value. An example of key value can be, what can I use? My name, that's all. Key value. Now, when you are defining a key value pair, you must have a space between the key. Now, the key here is, let me see if I can expand, zoom in this thing, appearance, zoom in, appearance, zoom in. Can you guys see my screen?
Yes, I can see it.
Yes, cool. So now when you're defining a key value pair, you must have a space between the key and the value. I can't do this. This is no longer a key value. This is just whatever it's called. But a key value would have a key, which is the name, column, then Dapo. So this is the key value. A key value can also be what? Okay, what state am I? States, I'm from Oyo States. This is another key value, right? Now, the structure of YAML is called a map or a list. So whatever we're going to be defining within YAML, just have it at the back of your mind that it's either a map or a list. So let's move on. What did I keep here? My age. I won't have my age here. Okay, let's say I'm 16 years old. Gender, male. So this is just key value, key space value. Now, what if you need multiple keys? Like, how do I put it now? What if what if you need multiple values under DAPO? How do you go about it? What you need to do is just to, define what we call a list or an array. So this can still be, let's say I want multiple names, right? I enter this guy and then use a space. You can use your space bar on your laptop. You can use maybe 2 spaces or 3 spaces, but whatever space you use must be consistent across. So let's say I want to use 3 spaces, 1, 2, 3, put a dash, DAPO, press enter. You can see automatically with Visual Studio Code, it has already detected that, okay, well, since you want to use 3 spaces, I will help you to make it consistent across. Next one, let's say I want the name Jane. Next one, what are the people on this call? Let's say I want Jemima. Next one, let's say I want Abiodun, and so on and so forth. So by the time you start defining your key value like this, it means you are defining what we call an array. So again, if I want to define another one, I'll just go, let's say states, same thing. I need to be consistent, 1, 2, 3, dash, Oyo. So let's assume that Jane is from Ekiti. Let's say Jemima is from Ondo and Abiodun is from Lagos. You can see this, I've defined an array. So what if you now want to further define some properties for, let's say, DAPO, right? You want to define some properties for DAPO. You can extract DAPO out this way, right? And say, let's be consistent, 1, 2, 3, dash, and say complexion for DAPO. DAPO is dark, right? Height, maybe 7 feet. Then gender, male. You understand? So let's say for Jane as well. Jane, complexion, let's say brown, right? Height, sorry, height 5 feet, and so on and so forth. So this in itself is called a dictionary. So don't mind all the old terms that is in dictionary, array, map, but these are the different terminologies, that you always come across when you want to create your YAML. So by the time you understand the fact that, I must not have something like this. Do you understand? I must not have something like this. Like, it needs to be consistent. That's why you can see this curly underlining underneath, meaning that there's an issue with whatever you are doing. So you must have to ensure that you have consistency across the space itself. Now, combining all of this together, all of this information that we've done now, is what we now call lists of dictionaries. By the time you understand lists of dictionaries, you have issues when it comes to creating the different, what we call YAML manifest file. So if you want to create a pod, you will need your YAML scripts, or you need your YAML definition. All of those things are called your manifest file, and it's a manifest file that you always create within Kubernetes that you always run within Kubernetes to create your pods and the different objects that you have. So now let us now combine all of this together. Let me remove this and say name DAPO, right? Details. No, sorry, I need this guy to be under name. Details can be, let's say, 1, 2, 3. complexion, dark. Heights. Sorry. Heights. Height is, let's say, 5 feet. Gender is male. So you can see how I've been able to combine a list and a list of dictionaries as we have. So the same idea here, you can also use that within the pod manifest itself. So let us go ahead and create our pod. Now, by the time you understand this concept of how to create lists, of how to create maps and dictionaries, then you'll be good to go. So let us now use that same concept to go and create pod. But before you actually do that, right, I need to show you some hacks. If you want to start creating your YAML manifest file, you can download Visual Studio Code, install Visual Studio Code, and come to extensions here and just type YAML, this YAML. This is like a helper tool that will help you to be able to simplify your YAML manifest file itself. So once you download it, enable it, and then come to this wheel icon here. That's the setting. Click on extension settings and scroll down here. You'll see something called edit in setting.json, and then just add this part to it. Because again, Kubernetes is not the only language that uses YAML. I'm sure you know that your Ansible uses YAML itself. So we're now coming here to define that Mr. YAML extension. Please, I need you to help me, to correct me, to ensure that whatever I'm typing within Kubernetes, right, follows the best practice. So just add this within the setting, then save it, close it, and reopen, and you're good to go. Do you understand? So once you just close this and reopen it, then you'll be good to go with YAML. So back to pods. Now, remember I told you that pods are the smallest objects that you create within Kubernetes itself. So let us go ahead and create pods. So now within pods itself, right, if you want to create a container to run within the pod, you need to create what we call the YAML pod manifest file, which is what you want to do. So let us change this guy. Let us change the name of this guy back to pod. So let's say we want to create pod.yaml, right? So what are those important things that you need to ensure? You need to ensure, okay, someone has a question. Please go ahead.
Dapo, there was no setting you went to. I'm trying to sort that settings where you edited that part. What did you go to under the?
Okay. Yeah,
I missed it. Because I'm trying to just do it, but I kind of missed it. I've installed the YAML, but I'm trying to. I went to the settings.
Yeah, settings over here.
Yeah. Extension settings.
Then you see edit in settings.json over here. Can you see
Okay,
it?
mine seems empty though.
Seems empty.
Okay. When you edit your own, can you just send me the? Okay? If you can just copy and paste that.
Yes, I can actually just copy and paste all of this for you. So you can just remove.
I'll sort
remove what you don't need. Yes.
Yeah, I'll sort that one there. Thank you.
Okay, let me just copy. Can I paste? Let me just paste it here for you. Okay, this is actually my Bitbucket integration, but you can also remove it.
Okay, no problem.
Okay,
Thank you.
Sent it. Oops. How do you send it here? Okay, I've sent it. Okay, so moving on. Let me just create this. So if I want to create my pod, right, I need what we call, though it will be very, very rare for you to create pod from scratch. By the time you just understand the language itself, what you don't need to do is just copy and paste from Kubernetes documentation page. Now, before I go on, Kubernetes, as I've said, is very wide. Just go to Kubernetes docs. How am I typing Docker? Kubernetes docs. Right. Kubernetes documentation is very robust. So anything that you need to do, creation of pods, what you don't need to do is just copy and paste. But just like I've said, you need to understand, what is it called now? You need to understand the basic language, behind creation of pods, which is what I want to show you now. You can see for pods, you can see API kind metadata, which I'm going to explain to you now. So it will be hard for you to, start writing pods from scratch. So that's why I say, what you need to do is just to copy this guy and where's my Visual Studio Code and just paste it here. That's it, and you'll be good to go. But we won't do this. We'll have to do it one after the other. So at least I would explain what it is they do. Yes, copy and paste is allowed, Liman. Okay, so now the first thing within your pod is what we call the API version. Now, because of this extension that I installed, right, this guy is going to be helping me a lot. You can see that after typing API version, it popped out, or it popped up different, API versions that I need. But the only thing I just need is just the first keyword there, which is API version. Once it comes up, just click on your tab key, and then you are good to go. Now, what does this API version do? It defines the version of the object that you want to create. And what is the object? We're creating a pod. Do you understand? So it defines the object of the pod that you're creating. Do you understand? So it could be pod, it could be services, which are still going to continue, to do. But the API version needs to have a version. For pod, it's called version 1. Press enter. The next one is what we call kind. Now, I've just defined to this YAML that I want to create an object. But for now, it doesn't know the object I want to create. What I just need to do is just to tell it that, okay, the version of the object I want to create is called pod and kind. And the kind is pod, right? So I just type kind. You can see as I'm typing kind, it is helping you to tell you that, oh, okay, Mr. Man, you want to create a kind, no problem, just tab me and you'll be good to go. So the kind here, you can see the different objects that we have within Kubernetes. So many. There's daemon set, there's deployment, replica set, job. But the one I want is what? Pod. I just type pod. And I'm good to go. Next one is called the metadata. As I'm typing it, I'm sure this guy will help me. Oh, okay. It didn't help me this time around. But metadata is, I don't know why it's not helping me this time around though. Let me try again. Meta. Okay. Okay, it's not helping me. I can just tab maybe like one, 2 or 3 spaces and I'll be good to go. Let's say 1, 2, 3 and type the name. You can see it actually recognizes the name. I don't know why it didn't recognize the metadata. Now, metadata gives information about the pod. So metadata is just information about an object. What is the information about me? My name is Dapo. I am 16 years old. I am tall. I'm 7, my height is 7 feet. I love watching football. I support Manchester United. All of those information are just the metadata of this pod. Right. So I can give it the name. I can give it name, my pod. You can give it any name you want. Right. Label. I'll talk about labels. Now, a label, or should I skip label for now? No, let me just go ahead. So under the metadata, you can see that this is similar to when we're creating our dictionary. And that was why I don't have to stress on that. You can see that this guy is the key value. Remember when we were creating Dapo and whatever, right? If I should do this, there'll be a syntax error because this is no longer a key value. But if I should just space it, I'll be good to go. Good. Now, what are the other information I need under my metadata? I need what we call a label. Now, a label we use labels when it comes to grouping. Meaning if I have 50 ports that are meant for front end and then another 50 are meant for back end, how do I group them together or filter them later on when I want to, start exposing these applications, maybe over the internet or for another API container to consume? I use label. So label helps me to, just like the name implies, labels. It helps me to label or identify or group my pod itself. So what I don't need to do here is just to type labels. Again, my helper will help me, labels. And by the time I press tab, you can see what I did. Let me go back. Labels. This guy has already identified it. If I should press tab, it is taking me to say that go ahead and start creating your labels. It has taken me to the next level automatically. So now, under the labels, you can give it any label. For example, let's say I want to group my application by the different applications. I want to group my services by the different applications that I'm running. I can just start with, okay, it's an application, right? Key value. What is this application doing? Let's say it's a login service. Press enter. Meaning I want to give this guy another label. And the type, let's say it's a front end. It can be anything. I can do this. I can say eat. What am I eating? Amala. Drink. What am I drinking? Coke. Do you understand? So the labels can be anything that would help you to group your pods itself. For example, if you have pods that you want the pod to be grouped by the name Amala, you can just give it a label, meaning these pods, they eat Amala. If you want to group another pod, maybe like 50 pods, these ones, they will be drinking Coke. You can just put them under the label. Do you understand? So the labels are not defined. So let me just go back to what I had. So the app is login service, type is front server. So if I'm now, after that, another important thing that we need to also take into consideration is what we call the spec. Very important. Now you can see that I am going back to the parents item here. I'm going back to the parents item. So you notice that I have defined a list and a dictionary. Do you understand? I've actually defined a list and a dictionary here. So the last one is what I call a spec. So you just type spec. This guy will help you. Spec, and then press your tab. You can see that when I did this, let me go back. You can see that when I did this, right, it did something spectacular for me. And that is why that extension is very important, because I want to create my own manifest file from scratch. I don't want to start, typing, enter, name, label. With that guy, once I have seen that it's a specification I want to create, just tab it. Automatically, it would bring out this for me. Now, a spec, what does it do? So a spec is it's telling you that, okay, fine, this is the version, the kind is pod, the metadata is here. Really, I've not done anything here. Now, the specification is now saying that what container do I want to run? So you can see why I say this is the pod, and within that pod, we now have containers. I now have to define the container that I have to run. Now, what will be under the container? Just the name and the image. Remember that when we did our Kubernetes class, we looked at how to be able to create an image. So it's that image that I will now reference here within the specification itself. Do you understand? So the name, let's say the name is, let's say Dapo app. No, let's say Dapo app. Again, whenever you are defining under your specification, always make sure that you try as much as possible not to do what I've done here. You can see I have front end here and I'm putting a dash. Really, just keep it simple so that you don't encounter any issue whenever you're creating your YAML manifest file. So containers, the name. Next thing is to define the image. I'll just go directly under this and type the image. So let's say I want to define what image can we use? Redis. No. Let's use Nginx. Let us keep it simple. Nginx. So Nginx, is a proxy server, that helps you to achieve load balance within your cluster itself. So let's just say that I want to define an image here. Now, take note that this container, what I've defined is a list or an array. A list or an array because it has children underneath. So container is a list or an array because it has all of this. Remember when we're creating that for this, the complexion is this. Do you understand? So now before we go ahead, right? If you want to validate what you've typed here, now there's a tool online that you can always use. It's called what is the name of that tool? It's called YAMLints. YAMLints, and it's a YAML check just to ensure that what you've typed here is correct and consistent. So just copy it. Let us see if it will bring out any syntax error. So once you just type, you just click on go. You can see it's telling you that yes, you have a valid YAML. Do you understand? And because we have a valid YAML because we already have a helper. We have a helper that is already helping us. Let's say, for example, I made a mistake here by doing this, right? The helper is already detected, but let us use that YAMLints to see what the YAMLints will tell us. So I'm sure the YAMLints will tell us that, boss, there's a mistake somewhere. Can you see? Did not find whatever, while passing a block mutation. Immediately, you know that there's an issue here. But this guy will not validate it for you. It won't tell you what to do. It will just tell you that did not find expected this on line 10. It's expecting that maybe you need to put a dash in front. But because of that extension that we have here, that extension would tell you immediately that all mapping items must start at the same column. Property image is not allowed. All mapping items. What are the items? These are the items. Do you understand? All mapping items must start at the same column. So just take it back to the same column and you're good to go. So how do we now run this thing? How do we run? Now we have finished defining our YAML. You can see how simple it is. We have finished defining our YAML. We now need to run it. So how do we run it? We need to use our kubectl. Remember when I talked about the kubectl? So this is my Kubernetes cluster that I just created before this class started. Before we actually create that, I created it on Azure. Let me just show you what I have on Azure. Go back to my home, virtual machines. So these are the two virtual machines that I created. I named it KS Master and KS Worker. So this guy is where my control plane, where I installed my control plane using kubeadm. So whatever I'm doing here is, it was kubeadm that actually helped me to do it, right? And that is the assignment I'm going to give to you guys. Create a two-node cluster that contains a master and a worker. Use kubeadm to be able to create the Kubernetes cluster. That is all. So that was what I did, and I have the both of them running. Okay, so let us go ahead. So few information before we go ahead. kubectl. If you want to retrieve an information within your cluster, just append the word gets. So what am I getting? I want to get all the nodes on my cluster. I just type nodes there, which I've done already. So it's telling me that I have my kmaster ready. What is the role? Is the control plane here. Anytime you see none here, it means it's a worker. So I can have several control planes depending on how I want my workload to scale. So this is the worker and this is the, so meaning my pods, again, it is not good practice to deploy pods on your master node because your master nodes is like the control plane, is like the brain, but you should always deploy your applications on your worker nodes. So you can have several nodes. If If I just spin up another server here now, I can join into this cluster. And if I should do kubectl get nodes, you see the node information, meaning I have two nodes. I have two worker nodes and one master node, which is also called a control plane. Are we good to go? Yeah, we're good to go. Okay. I think I have a question. I have a question. Okay. Israel, please go ahead.
Okay. From the manifest file you wrote a while ago, when you specify the container image and the name. Okay. My question is, since this is a container, are we going to expose any port at this level? Like, or is it going to run?
We'll come to that. We'll come to that,
okay.
Israel. We'll come to that. So, well, that's a very good question, Israel. That's a very good question. But remember, remember that when we were creating our image, were you around when we did the Docker class?
Yes, yes.
Good. Remember that when we created our image, within the Docker, okay, good. I even have a Docker file here. Within this Docker file, we already exposed port 8080 here. Do you understand? So it means port 8080 has already been created within the image. So the only thing I just need to do is just to specify, let's say at the end of the day, the name of this image is called Nginx. The reason I don't need to do is just to specify the name of the image. And then I will show you how to expose it within this class.
Okay, thank you, yeah.
Good, so let's go ahead. I'm just going to make the class to be very simple and straightforward. Do you understand? So that we can all get the concepts. So let us create this. I'll copy this and I will go to my server, right? So what I don't need to do is just to create a file, vi, let's say test pod, create a file, test pod, then .yaml, because definitely Kubernetes only understands YAML. So I need to put an extension .yaml. So it can be spelled this way, YAML, or I can do it this way, YML. Anyone, let me just follow YAML. It will run. So vi this, then paste that guy, save it. And how do I run this now? Very simple, kubectl creates, because I want to create this pod. What am I creating? I'm creating test pod.yaml, but this is a file, so just define the file. And how do you define the file? -f, then specify this. That's all. So kubectl, which is the command line to create objects, space, what do I want to do? I want to create that pod, right? Where am I creating the pod from? From a file. Just specify the file with -f and be good to go. I can also use apply, create or apply, meaning kubectl apply -f, the name. Now, what is the difference between create and apply? It's very simple. Now, whenever I want to do create, it would create the pod for me. But if I now want to update it, that's where the difficulty would come into play. So I usually advise people to always use apply, because apply would still help me to make adjustments, make amendments. Because if I should do create here and I now try to modify the pod itself, it will tell me that, oh yeah, you can't do this because you didn't create this pod with apply. Do you understand? So let us create this. Let us keep it simple and use apply. So you can use create or apply depending on your use case. So I'll just use apply over here and do this. So it's telling me that pod, the name of the pod, which is here, you can see my pod has been created. So how do I now check the pod itself? Simple, kubectl gets pods, or you can use get pod or get pods. Press enter. So what does this mean? It's telling me that my pod, which is 1 of 1, it is running, it has not restarted, and the age is 23 seconds ago. So how do we now check? Okay, this pod that we've created, so what is it doing? Like, what does it do? Like, I want to get more details about this pod. So what command do you use? kubectl describe. What do I want to describe? Pod. What pod do I want to describe? My pod. Enter. So what does this tell us? Let us just scroll up to see. I want to describe this pod. Remember that this is where we're coming from, guys. I don't want you to miss this thing. That's why I'm just taking my time. Remember that this is where we're coming from, right? kubectl Kubernetes will be the one to help me run my pod. So I've created my pod here. So I've created my pod. And within my pod, I have the container running, which is what I've just done now. So this is my pod, and this is my container. So let us go back. So what is this telling me? It's telling me the name, namespace. I missed namespace. I will talk about namespace after now. Very important. So namespace, service accounts, node. It is telling me the node that this guy is running on. You can see that I didn't tell Kubernetes to deploy it to this particular node because of that intelligence, because of that scheduler. Scheduler has said that on this worker node, there are many resources there. Here, so you can see that within my cluster, I have the master and the worker. When I deployed it, I didn't say that Kubernetes deployed to this particular one. It was intelligent enough to schedule the pod on the worker node, which is very, very interesting. So let me go back to my server. So it is telling me the node and the IP address, the start time. You can see my labels, login service, front end, the IP. We'll talk about networking so that you understand what this IP means. Why am I having two IPs? I would explain. And then you remember container D, guys. Remember container D, telling me that this is the container engine. Abiodun, so this brings us back to your question. This is the container engine that would help Kubernetes to run this container D, right? Now that image, this is the Nginx, this is the image ID, right? And some other things that I have here. But what I would just want to bring your attention to is what really happened. Do you understand? So these are just the events. When I typed this command, kubectl apply, these are all of the processes. Sorry, let me just clear my screen and show you again. So kubectl get ports. So kubectl describe, describe pod, my pod. So these are everything I did. So it scheduled it, it pulled the image. After pulling it, it now created it, and we're good to go. You can see this guy. So really, that was why I went through the effort of explaining the different components. So whenever you see kubelets, you would understand what kubelet does, right? Remember, kubelet is like the ambassador that is running on this worker node that is always interacting with the API server and the control plane. You can see the scheduler. So the scheduler was the one that scheduled it, and then the kubelet, right, was the one that now, that is communicating with the cluster, and it's good to go. Good. So after that, let's quickly talk about namespaces. Now, namespaces is a way to divide your cluster resources between multiple users. So, for example, let's say in a cluster, right? This cluster right now, right? You are running production and test workload within this particular cluster. So you can create a namespace within this cluster and then tie resource quotas to say under the test cluster, right? I want to specify that any pod I deploy should go to this server, right? It should go to this server. And now, one thing I just want you to know is this, before I go too far, within the cluster itself, right? the Kubernetes has combined all of these guys together. So let's say the utilization for this guy is 5 CPUs. Here, 5 CPUs and maybe 16 gig of RAM. Right. So across board. So now, remember, oh, let me just do it like this. Remember that Kubernetes, right, is not seeing these guys as you are just a worker, you know, you are not doing anything, like you are just there. What Kubernetes is saying is that it's saying, sorry, just a minute. Sorry, I had a call. That's snooze. Okay, so Kubernetes is saying what? It's saying 15 CPUs and 16 times 3, 48. It's saying 48 gig of RAM. That is what Kubernetes is saying within this particular cluster. Now, a cluster is just combining all of the resources within this particular node, and it's combining all of these resources within this particular cluster. It's grouping them together. So Kubernetes is saying 15 CPUs and 14 gig RAM. Now, what if I now want to divide, let's say within this cluster, I want a particular space that is only test workloads. For example, let's say for the testers, they can actually use the test cluster. For the dev guys, they can use the development environment to be able to, you know, do their dev environment. They will now have production. How will I be able to use this cluster to be able to isolate these environments? That is the concept of namespace. So what will now happen is that you will now define a namespace, say dev cluster. You will now tell Kubernetes that Kubernetes, any workload that is going to the dev cluster, it must not use more than 4 CPUs and 4 gig of RAM. Just how I'm trying to say, it must not use more than 4 CPUs and 4 gig of RAM. It means you are kind of like creating an isolation, you know, within that particular cluster itself. But now saying, okay, well, since it's a test cluster, Kubernetes, these workloads that are going to the test cluster must not use more than 2 CPUs and 2 gig RAM, because come on, it's just a test environment. While the remaining can now be allocated to default, or you can create production cluster. But by default, if you don't create any namespace, a namespace that comes natively to Kubernetes is called the default. So anything that is being done, whether dev environment, you know, will just be going to the default. And that is not really a good practice. It means your dev workloads can even overburden the entire cluster itself. That is why you need a namespace to be able to differentiate that. So how do we create a namespace? It's very simple. But before that, let us, oops, our time is fast spent. So. But before that, let's do kubectl. I want to get namespace, the namespaces that I have here. So that was the command. Sorry, my spelling. So another thing is, because you do so many kubectl typings, what I just do most of the times is just to do something called alias, right? It's just a shortcut, you know, so that I don't need to always type kubectl, because you can see I typed the wrong kubectl. I don't like typing that kubectl because I'm very busy. I'm trying to, you know, troubleshoot, you know, my cluster, and now I have to keep typing kubectl. A short form to do that is just to do alias. What is my alias? I want to say K and type it to kubectl. That's all. So whenever I want to get the names, I just do K get port. The same thing. It will do the magic. So let's say K gets namespace. it will get all the namespace there. Or you can do k gets ns. Is a short form for namespace. So what do we have here? We have different namespaces. Now, all of these guys, please, in anything you do, please don't mess with these guys here, because these are like the cluster namespace that actually came with QBDM. So you might not want to mess with this, and please don't deploy anything to these 4 guys. So if you can just create one, okay, this was one I created. You can just create one. Let us create one now. How do we create a namespace? Does OK create namespace as a dev namespace. That's all. Then do k gets namespace. You can see our dev namespace. So that would now help you to create a namespace and isolate, what is it called? Isolate your workload. So let's say this other guy now that we did, this pod that we created. Let's say we want to create this pod within the, what's the name of this namespace that we created? Dev namespace. What I just need to do is within the metadata, you can just type namespace here. This guy will help you and paste the namespace there. Meaning, by the time I deploy this pod, it's going to deploy within the namespace called dev namespace. And then if I should do, okay, let's even do it. Let's even do it together. Clear. So let's get our pod now. So I want to delete this pod. It's just kubectl, which is k, delete pod, my pod. That's all. So kubectl get pods. You won't see anything there again. So let us now create that guy again. Oops. Let's say vi pod namespace.yaml. Insert this into it. Save it. And cube apply -f, right? And this. So look at something. If I should do get pods, what do you think will happen? It will tell me that no resources, but I just created a resource. So by default, right, if you don't specify a namespace, right, your object is going to be created within a default namespace. But I want to try and get the pods within the default namespace. Yes, no resources, because I have told that pod that it should go and deploy within the dev namespace. So how do I get it? It's just k get pods. You now specify namespace. Namespace is equal to what? Dev ns, right? So just enter it. That's when you can see it. Meaning you are telling the Kubernetes cluster that please go and get my pod within the namespace called dev ns. Am I making sense?
Yes, yes.
Okay, cool. So time is fast spent. Should we go ahead just to talk about a few concepts and we'll call it a day?
Yeah, sure.
Go ahead.
So Dapo, when you created this namespace, you didn't do any configuration. You know,
No, I didn't do any configuration.
So in this namespace that you created as a default now, let's say you in that, can you go to that diagram?
Okay.
You know, you were saying something about each has 16 gig, 5 CPUs, and all. Now that you have created this namespace, what memory is it going to assign to it?
Yeah, good question. And that's another, well, it's beyond the scope of this class. So you can actually do what we call resource quota allocation. That's where you now say that, okay, within the dev namespace, this is the quota that I want to allocate. Let me show you.
Are you going to have a part 2 of this class?
Ah,
I don't think you can finish it today because
and that's why I
it's
said I want to
it's
kind of
quite.
like keep it
But I think
simple.
what you can do for us is actually just give us a material that we can use to watch and just have a better idea.
Yes. So this would answer your question.
Okay.
So you can see resource quota work like this. Different teams work in different spaces, which can be enforced with RBAC, which is another concept. So the administrator creates one resource quota for each namespace. Can you see it? For each namespace. So you just have to kind of like create a resource quota and then tie it to that guy, which you can just check how to do that here. You can see the kind is resource quota, and then you now specify the CPU and the number of ports you want, the memory. Do you understand? And this is now very, very important. This is another concept called the scope selector, meaning you are saying that all the labels, as you're creating the ports, right? Once they match this label, once they match these labels, they should go straight, or I can even set it like this, env, and do dev. So I will now have to define this within the resource quota manifest file. Now, what this would say is that the resource quota is sitting at the gates and is seeing that ports that want to be created, is checking their labels. Okay, well, this label, what is the environment labeling that is there? En dev. Is it within my resource quota scope selector? Yes. Oh yeah, go to the dev namespace. Do you understand? So that's why I say it's beyond the scope of this class, but I'm sure that if you should read the documentation very well, you will know how to be able to segregate, the different stuffs that you have. Does that help?
Yeah, that helps.
Okay. So, man, you guys might want to give me another 15 minutes so that I will just round up with services. I really want to stop at services so that we would, what is it called? So that at least we would know that we are done with services and we'll be good to go. So please just give me another 15 minutes and we'll be good to go. Okay, so where did this stop? Yeah, so again, in Kubernetes, there's what we call controllers, right? So I'll just talk about the controllers. I won't define the YAML file that we have. Now, controllers, let's say, for example, right, we like to have more than one instance running so that when one fails, other applications can be available, which provide what we call high availability. Now, the controller itself ensures that we have high availability. And this is a common interview question. They will tell you that what are the types of controllers we have and what are their uses? Very simple. Controller just ensures high availability. Now, the two types is what we call replication controller and replica sets. So replication controller and replica sets, they are the controllers that we have within Kubernetes, and they just help. The basic function of controllers is just for load balancing and scalability. So the name they actually call that is high availability. So what is high availability? Just to ensure that my application is up and running 24/7. And how do I ensure that? It's through load balancing and then scaling. Do you understand? So how do you create a replication? Okay, so I talked about replication controller and replica sets. Now, what are the differences? Replication controller is the older technology for replication, while replica set is the newer technology. But in this class, right, we'll stick to replica sets. So how do we create a replica set? Now, another common interview question again, because I love to, as I'm taking a class, I always love to kind of like give, based on my experience, the interview tips and all. Now, they will always tell you that what is the difference between replication controller and replica sets. Do you understand? And the basic difference is that replication controller, I've said I would want to go deep into replication controller uses what we call equality-based selectors. For For example, let me just show you, where's my Visual Studio Code? Let me just show you an example now. Now, replication controller uses what we call equality-based selectors. Now, this is a selector. Let's assume that this is a selector, right? Now, the replication controller would identify my pod immediately because of this selector, because it's actually equality-based, or it can be used this way: env is equals to production. Or you know what? Let's not go too far. Just know that because I'm actually rushing. Replication controller uses what we call equality-based selectors, while replica sets uses equality-based selectors and set-based selectors itself. And what that means is that within replication controllers, right, I can define something like this: environment is equal to prod, right? Or let's say the tier, I don't want the tier to be front end, right? Now, the replication controller is going to check within my pod definition file to see if there is an equality-based statement defined here, and it's going to apply whatever rules I have because of this equality-based, right? But set-based selectors can be something like this: env in, let's say, production and dev environments. So the replication controller does not recognize this, doesn't recognize this statement. But a controller that recognizes this kind of statement is a replica set, because they work on both equality-based and set-based selectors. Very, very important. So moving on, how do we create a replication, a replica set, right? The syntax is very simple, and I will just define it here. So let us quickly create a replica set here. So why do I need a replica set? I need a replica set because I want to ensure scaling, right? So what do? We get the API version. API version, as usual, is v1. Kind is what is the kind that we're creating? We're not creating a pod this time around, but we're creating a replica set. You can see it here. The metadata, what is the name? Name is, let's say, my replica set. Labels, let's say app, my app, enter. Let's say the type is front end. Remember the concept of labels, right? So after this, what's the next thing? Next thing is to define my spec. You can see how this guy is actually helping me. Now, because I want to create a replica set, right? It has brought out what we call a selector. I'll talk about the selector now, but let's just finish creating it. Match labels, the type. Let's say I want to match front end. So the next thing I have to do is to create the templates. Remember, okay, good. Now let me just stop here so that I don't go too fast. Now we don't have issues with this, right? API, the kind of replica set, metadata is just the information of the replica set. Remember, the mindset is I want to be able to create. Remember that this pod that we have running is only one, right? We want to be able to scale that pod so that we have like 20 pods running to ensure load balancing and high availability. And what can actually help me is the controller. And a type of controller that we're using is replica sets. So now the spec, within the spec, I define, again, remember that I told you that the spec is just the information about the kind of object that you're creating. Within the spec itself, I define what we call a selector. What does this selector do? Selector is saying that, Mr. Replica sets. Now I need to scale my pod. But how will this replica set know the pod to scale. Remember that within this pod, we already defined our labels as what? env dev type front end. We're not telling the replica set that, Mr. Replica set, I want to scale this particular, I want to scale a pod, but how do I now know the pod to scale? You will now define that, please match the label that has type front end in any pod that you can see. So it's matching this label. You can see the label here. It's matching this label, and we're now specifying the kind of label to match, which is what we have within this replica set. So selector, match labels. What is the label that we want to match? We want to match the type front end. I can, remember, I defined this. I said it can define this as Amala or club. Can define this as, I'm sorry for Chelsea, club, Chelsea. Come to this replica set. What am I matching? I want to match the pod that has this label called club, and what? Chelsea. If I come here and put Arsenal, it won't do anything because it has gone to all of the pods to go and check, okay, is there any pod with this label? You tell you that none, and then it won't work. So let us go back and go back here as well. So by the time you get these concepts, you'll be good to go. So what is the next thing I need to do? I now need to specify the template itself. So what is a template? A template is just telling me that aside from matching the labels, what is the pod that needs to be created? So I just need to copy all of these guys that is here, copy all of this metadata that is here, all of this metadata, and then impute it under a section called template, which I'm going to do now. So templates, sorry, templates should come under selector, yeah. So templates. So the templates will now consist of the metadata, the same thing that we defined there. What is the name? Name is, okay, let me just see if I can copy and paste over here. I just hope it works. Hope it works. It won't work. That's why I don't really fancy copy and paste. But really, what we are doing is we are just copying this metadata information that we have within the pod there and just pasting it here. So let us quickly type it. So metadata, I have what's the name. What is the name? My pod, or you can just give it anything. My pod. Labels, right? What was that label that we gave to these two guys? Let us copy it. See. Okay. I don't need to align it again. Labels. Then remember spec. Spec would tell us the container itself. So spec should come under the metadata. That's why I love using Visual Studio Code. So spec, you can see automatically it's going to tell me what is the name of the container. Let's say I want to create ng. Let's say I want to create a front end app. Then image that I want to use is ng-inx. Then one last one is enter. It's now under the same templates. I now define what we call a replica, meaning how many instance of this pod do I have running? Do I want running? You now define it as I want 4 of this guy to be running at every particular point in time. So guys, I am done defining my replica set. But in real life, you won't type this thing, one after the other. As I've said, just go to Kubernetes docs, copy what you need to do, understand what this does. Don't just copy and paste. Understand the different functions, and you'll be good to go. So let us create this. So let me clear my screen. VI, let's say daas replica sets. Oops, sorry. I need to, let me cancel this out. I didn't define .yaml. So let's create this. Right, save this. So what am I applying? -f, that is the file. And I'm applying this and okay. So what do we have here? Name do not match replica set in version 1. Okay, good. I have done a mistake somewhere, and you can see that I'm not cramming this. Do you understand? So from the error, I know it's telling me that resource mapping not found for name, no matches for kind in version 1. So you remember that a pod has its own version. A replica set has its own type of version. I just have to include apps this way, and I'll be good to go. Do you understand? And I was able to kind of like identify it because I've used replica sets, replication controllers a lot. So I know where the issue is coming from. So the API version for replica sets is not V1, but for pod is V1, but for what's it called now? For replica sets, you have to add these apps / and you'll be good to go. So let's just go back and edit this guy. Sorry, I love VI. I don't know why it does weird. So apps and save this guy. So let's apply it again. Does not match its front end. Okay, what did we copy again? So let's see where the issue is coming from, guys. Where is seeing it? Oh, sorry. So this should be type and not it. Hello, are you guys following me?
Yes.
Exactly. So let us change it back because it's not seeing the labels. Remember that when we're doing our definition, we just type it. Else it would have worked if I have it over here as well within the labels. Let us go and rectify that and we'll be good to go again. So this should be type. And let's go and create it. Hopefully it creates this time around. Good. So it's created now. So what do we need to do? kubectl gets, what do we want to get? Replica sets. So you can just type replica sets this way and you'll be good to go. So you can see what is happening. It's telling me that the replica set has 4 pods running, right? So let us get the pods. Get pods. Now, what have we done so far? Let me just show you the diagram of what we've done so far. Now, we have defined within our manifest file that we want to deploy a pod, which you can see here. And we want the pod to be, want the pod to have 4 instances. 4 instances of the pod must be running at every particular point in time. How do I do that? I need to define a replica set. So a replica set will ensure that I have 4 of this guy running at every particular point in time. So this is 1, 2, let us say example, this is 1, 2, 3, 4. We can remove this guy running at every particular point in time. Do you understand? So now let us do one magic. What do you think will happen if I delete kubectl, delete this pod? Sorry, delete pod.
It will create another one if you delete it.
Good, beautiful. So if I delete this guy and do get pod again, can you see? It has immediately created another one. You can see it has created another one immediately. You can see that this guy would ensure high availability for you. That is the function of the controllers. So what do you now do if I should now delete this guy? If I want to delete this guy and this guy, in fact, let me even delete 3. What do you think will happen?
It will create Another 3.
Exactly. So is that stubborn? It would always ensure you have high availability at every particular point in time. So even if one goes down, immediately see, we removed it and it is back up automatically. So that is the function of the controller. So lastly for today, let us talk about deployments, and then we'll call it a day. Now, replica set is sweet, right? Replica set, which is a controller, is very, very sweet. But what will now happen if I want to do, what is it called now? If I want to do deployments, if I want to do things like updating my pod, things like doing rollback and all. And mind you, in Kubernetes, there are 2 types of deployment strategy that we have. The first one is called a rolling update, which is the default. And then the second one is called a recreate method. Now, by default, Kubernetes uses the rolling updates. So what I've done right now is a rolling update, meaning I deleted one. Okay, no, sorry. What I've not done is not a rolling update. A rolling update is saying that if I need to update this, let's say within this, so I'm just watching right now. Let's say within this particular manifest file that we have, I've changed this guy to Reddit to Redis image now, and I say that the replica should be 4. What will happen is that by the time I want to deploy this, it will not delete everything I have automatically. It will do what we call a rolling update. And what that means is that it's going to, make the update one after the other. So it will make the update for the first one, right? When that one is updated, it will now go to the next one. It will ensure that this first one is up and running. That's for the Redis image, up and running. It goes to this next one. It's rolling the updates. It's doing it so that there's no downtime, which is another important interview questions. What is a rolling update? And that is just used to ensure that all ports actually deployed first before the new ones are created. Do you understand? That is, the old ports are faced. It creates the new one. It faces the old port. Create another new one. Faces the old port, like that, so that there is always, high availability itself. So now, what really helps me to achieve rolling updates is what we call a deployment. So a deployment, this is a deployment itself. So this is a deployment itself. Remember, we have, this is a replica set, right? And this is where we'll stop for today. Replica sets, right? Within the replica set, remember, it created 4 ports. 1, 2, 3, 4, right? This is what the replica set. But the replica set would only help me to achieve scalability, the desired state. The desired state is 4 that I showed you here. It would also help me to achieve what we call self-healing. So that if this guy goes down, another one comes up automatically. That is just what replica set can do. Now, the deployment will now wrap itself within the replica set to ensure that I achieve what I call updates, which I don't define as what rolling updates, and what rollback. So that by adventure, there was a deployment that was made. So this is called a deployment. By adventure, there was a deployment that was made, but that deployment was actually catastrophic, right? Deployment will help me to roll back to the desired states. So, and that brings us to the end of the class. Though I would have wanted us to talk about Kubernetes networking, talk about services, the different services that we have, cluster IP, what are the other 2, node port, load balancer. I would have actually wanted to talk about it, but because of the time that we don't have, maybe you might just need to read more on that and we're good to go. So that brings us to the end of the class. Do you have any questions? So that I will just take that. So questions, please.
Okay, so I think one question I just want to ask is maybe from your experience, do you think do you recommend Udemy as a better resource for someone to actually learn Kubernetes properly?
Yes, sure. I would recommend. So I won't recommend only one resource. I will recommend different resources. Do you understand? Because I started by learning with this guy, though it was with this Kubernetes doc, though it's quite voluminous, but at least that was the first understanding I got. Then there's this guy, Moonshad on Code Cloud. Very, very, very intelligent guy. So you can also use Code Cloud. Yeah, this is the guy here.
Yeah, I think the one for Udemy, the video I have on Udemy is also the one treating it.
Yes, sure. The guy is
Also-
very, very good when it comes to Kubernetes. So you can him. You can also use Nana. You can also use Nana.
Yes,
It's my
Nana.
biggest fan. Yeah, Nana.
No,
Yeah,
I have,
you can see
I have
Nana.
the videos. Yeah.
So, but usually you might not really get the full context unless you buy our courses. So I think I've used some of our courses in the past and it's very, very helpful. So YouTube will just give you like a general overview. You can't learn Kubernetes in 3 hours. It's not even possible. Do you understand? So Udemy is very good. Moonshot course is good. You can use Nana. Then there's this other guy as well. I'm trying to remember his name now. When I remember his name, I would maybe like send it across to you. What's the name of the guy? I'll remember. But my two all-time favorites, Nana and Moonshad.
There's one guy, Imran Telly, is also good.
Who is that?
Imran Telly is also good. He's on Udemy.
Imran, yeah. Imran. There's so many, creative guys out there. So many creative guys. Yes, Tech with Nana on YouTube, Imran Telly, Code Cloud. Yeah, good. So I think that, but man, Kubernetes is, you need to just continue to learn, right? So please, another caveat that I will give to you is please understand Kubernetes very well before you deploy it within your organization. Please, I've done that mistake before. I thought I had known, everything within Kubernetes, and then I deployed it. I didn't even go to dev. I just went to production. I deployed application. Applications were running within a month. But by the time it now came to scalability, I didn't really define how the pod should be scaled. Because when traffic was now coming in, so I did load balancing, use Nginx. When traffic they were now coming in, there was not like a tight constraint because I didn't define what we call resource allocation within the pod. You know that your pod can actually use up to a maximum amount of CPU and memory. Your pod can use the entire resource for a node. Do you know that? So I didn't really do that for the pod. So there was this particular API, that communicates with other banks. So that API was consuming, and of course that API was actually running within, I think, 5 ports. And then all of the ports, they were doing what they ought to do, but then they were using, high CPU memory. And at the end of the day, they brought down the node. At the end of the day, I was not like, production was now, people were now having issues, calling the APIs. I now saw where the issue came from. I now had to do what we call resource constraint on the pod itself, meaning if a pod is consuming, let's say 1 gig RAM and is using, let's say 20% of 2 cores, right? Then automatically spin up another pod for me, allocate that guy to it until the load that is coming in is now load balanced across. Do you understand? So it's very, very essential. Please understand Kubernetes very well. It's very, very tempting whenever you are working with it and it's sweet, your pods are running well. You'll be tempted to just, make it run in production. Please don't make the same mistake I made. Then always use the different tools that I talked about, Minikube, micro kits, KubeADM. Just spin it up, work with it, play around with it. And when you are good, you might not even want to even move to Kubernetes immediately. You can pick up what we call Docker Swarm. Right? Docker Swarm does almost the same thing that Kubernetes does. Very, very easy. In fact, it's even easier than Kubernetes. What you just need to do is just to define your stack. Again, the stack is just YAML. Define your stack, define the number of containers. Again, the concept of Docker Swarm works with services, right? Now, services are just like ports. You can now define the number of services that you want to be running at any particular point in time, and you'll be good to go. So we use Docker Swarm within our production environment that we have today. As we are speaking, we have applications within Docker Swarm. We also have applications within Kubernetes as well. Do you understand? So you can just start from Docker Swarm, then you scale to Kubernetes. But it will be much more sweeter when your control plane is being hosted by your cloud provider. Very, very sweet. So I think that is it. Does anybody else have any other question before we go ahead? Then one last thing before I forget, it would be good to continue to learn. As you're learning, you can also write the Kubernetes exam itself. There are different exams. There is CK, which is Certified Kubernetes Administrator. There's CKAD, Kubernetes Certified Application Developer, I guess, CKAD. There's CKS, Kubernetes Certified Kubernetes Security Course as well. So you might also want to kind of like just, test your knowledge. I've written CKA. So CKA is like the most taxing. I wrote CKA 3 times. The first one, I failed. Second one, because I was using dumps, I just wanted to kind of like get it and just move ahead. But dumps did not help me in the real exam. Do you understand? But then the last one, I just had to, I went back to the basics. I watched videos, read so many materials. And at the end of the day, I was able to scale through during my last try. And the last try definitely really helped me a lot. You understand? So, so that will also help as well. All right. So if you have any question, kindly come up with the question and we'll call it a day.
Yeah, before we go, yeah, I was curious to know if you have a group channel where,
If we have a what?
a group chat, something.
Oh, yeah. So, okay, Michael, this is your first time, right?
Yeah, my first time. Where about?
Okay, well, we've been running this bootcamp since July ending, and yes, we've actually been running this within like since July. We've actually done so many courses, so many. So I would just advise you to go to our YouTube page, right? Go to our YouTube. Yes, we have a platform, a DAS platform where we convey information about jobs, assignments, just different information as regards the bootcamp. But unfortunately, the bootcamp will be coming to an end next week. Next week will be our last class for the year. Or if there's any other information, we'll kind of like pass it across. But next is going to be our last class where we're talking about CI/CD, right? But another bootcamp, fortunately, we'll have another bootcamp in January. And that one is even going to be much more robust than this bootcamp. There will be so many measures put into place. So I would just advise you, follow us on LinkedIn. Like LinkedIn is where we pass all our information. So just go to our LinkedIn page and just search for daas.ng. DAS is DAAS.ng, or you search for DevOps as a Service Nigeria. You cannot miss it. Then if you just want to have a glimpse of what we've been doing for the past, I think 3 months, 2.5 months, thereabouts, you can just go to our YouTube page and also search our channel, daas.ng or DevOps as a Service Nigeria, and you'll see all the videos that we have. Also follow us so that by the time we upload videos like the one we just did today, I'm going to upload it. By the time we upload the video, you get a notification. So I think that is that. Then for information, quick information, we'll be having Terraform class on Wednesday. Terraform class on Wednesday by 8 p.m. Then we'll be having the Kubernetes presentation class on Friday, and that will be the last class for the boot camp. So you might not want to miss that. Friday by 8 p.m. as well. And the assignments, which I'll still paste, is just for you to bootstrap a Kubernetes Cube ADM and then you present. The next week, Saturday, again, is our CI/CD class, which would pass more information as the CAT starts. All right, so I'll just leave the floor for my co-founders. Miracle, does that answer your question?
Yeah, that helps. Thank you very much.
Yeah, so I'll just leave the floor for my co-founders, Sheung or Nuruddin. I don't know if they're still online. Sheung, Nuruddin. Okay, Sheung, yeah.
Wow, thanks so much. I'm not surprised. Anytime that was whenever I see that, I've been pleading with him that don't take too much time. I was looking at the whole thing. However, I must confess, when we started building the foundation, building from scratch, so Kubernetes is very interesting. I remember when I started learning Kubernetes, I would watch and watch the video like, what are this? I don't understand this thing. I don't understand this thing. You are talking about somebody that knows it very well and it's not very well. If you are not very careful, is one concept that is not very easy to grab. But the way he has taken it is up to me. He has made it very easy for beginners. I don't say beginner that will not be able to grab the concept this after. It's quite easy. Thank you for your time. And the numbers are well, very easy now. I'm not surprised. It just shows that it's not everybody that can keep up with the journey. The DevOps world is one that is very demanding. I remember we made mention of this when we started. That is a very demanding journey. You just need to keep focused. Don't be distracted. Don't get anybody distract you. I mean, just keep focused. Put your eyes on the goal. Always at every point in time, the eyes should be on the goal. What you really want to see. So it don't scare you. Like I always tell people, what are coming for it? I tell them the most important thing is you have the desire to learn it. You want to commit to it. Whatever you feel is across or
Sorry, Sean. I don't know.
cannot-
I don't know if it's my network, but I can't hear you well. Like it's faint. I don't know if it's from my side alone. Sorry.
better now.
My own end too.
Is it better now? Let me rejoin. Let me leave and rejoin again.
Okay.
Is it better now?
Yes. Yes. Better.
Okay, maybe I just needed to refresh the app. So I was saying that we want to thank Dapo for the time, and he made it very easy, very easy. The way he built it from scratch to the very top. Thanks for the time. And this Kubernetes is one technology that could be very difficult for people to grab at first, but he has been able to break it down. The way he was introducing the examples he even gave, look at, if I was just wondering that, wow, there's no how you won't get it. I mean, if you just, even without watching the video, if you can just play all the examples that he gave you, you can quickly place those components together and you understand the technical bits around it. Thanks for the time. And the numbers, we are not discouraged. It just shows that we have some set of people that are choosing to be persistent and not to be deterred across by challenges ahead or in the journey. So I always tell people it might not look easy. I remember we made mention of when we started our first inauguration, we emphasized on it, saying it will be very demanding. The DevOps world is a very demanding one. It's not for children. It's not for I just want to It's for those that are really determined. You are focused. You are not losing focus, because it will be guess what? The more you learn, the more you still need to learn. As you understand this one, before you know it, there are other things that are coming up again. In fact, Kubernetes, there are a lot of changes that are happening now that you need to keep on learning every day to keep up. Otherwise, you just be left behind. So don't be discouraged. Just continue. Don't let the number discourage you. Put focus. Keep your focus intact. Keep it intact, and continue to learn more. Even after the boot camp, it's not over. You must learn every day. I review my materials every day. Check what is happening around the world. What's happening in this space? It's a space that is still evolving, and a lot of new things are being introduced. A lot of people are coming into that space, and that's one bit about open source. Development is always there. Today you have seen 5 things, in another 1 week time, somebody has introduced 10 things on it again. So let's not be discouraged. Let's continue to learn. And I must say it for Docker, for Kubernetes, most especially in the DevOps field, it's not enough to watch videos. You must get your hands dirty. When you watch videos, you can forget it. But whatever you try with your hand, set up your own lab. He gave some platforms that you can use to set up lab. Set up your own lab. Try and whatever concept it is, you can. And that's one beauty about IT. I always tell people, it's not like engineering that you are scared of. If I go and set up this, what will happen? You can set up a lab, scatter everything. I mean, just make things mix up, see the errors, try to explore. As you explore, you see errors, you encounter errors, you fix them, you learn. You learn. If you have tried several times and it didn't work, you now start seeing, oh, so these are the steps I did wrongly that made me not to work. Okay, you know it better. That's where you master it. It's not enough to just watch videos. It's not enough to just cram the theory. When you watch the video, set up lab, play along what you've been given in the learning materials, even go beyond it. You go beyond the try and see, okay, they gave me 4 things. Maybe you have been on even the videos, maybe the videos you have a cluster with 5 nodes. And you can see what will happen if I want to do 20 nodes. Can I see if I can run 30 nodes? Scalability, try to practice, and that's the only way you can grab it better, other than just watching videos. And don't try to get very methodical with the way you're learning. Don't try to learn. You want to learn everything at the same time, one after the other. Get a good grasp of Docker. You finish Docker, you enter to Kubernetes. Just keep learning. Don't feel discouraged. And we must appreciate every one of you. I mean, it's not easy for several weeks. Keep your weekend free so that you can be part of the bootcamp. We know it's not easy, and we are not taking it for granted. We appreciate every one of you, and even those that have been giving us good comments, they are all well appreciated. And that is the whole essence of having this foundation. We want to see giving back to our community. And I want you to know that it shouldn't stop with us. You shouldn't stop here. Whatever knowledge you have acquired, try to build more on it by passing it across to others. See what value you can have to other people. Thank you very much.
Thank you, Sean.
All right. Okay. Nudin is no longer online. All right. Thank you, everybody. Thanks so much, Sean. So we'll see you next week. For our mentees, we'll see on Wednesday, or for so many people that actually wants to join us. For anybody that wants to join us on Wednesday for the Terraform class, you can just join us on Wednesday, 8 p.m. Friday, for the Kubernetes presentation, and then on Saturday we'll be going to CI/CD, where we'll talk about GitLab, TeamCity, Octopus Deploy, different CI/CD tools that you're familiar with. All right, thank you, everybody. Have a great weekend.
Thank you.